This brings us to our next objective, which is solving equations. When we solve equations, we have what I call the golden rule for equations. The golden rule for equations. This one you must follow always. This is a major rule. I've started. Be sure to learn this rule thoroughly. Putting it in the language of do unto others what you would have them do unto you, we can say, do unto the left what you do unto the right. The left and the right are the two sides of the equation that you're working with. So do unto the left side of the equation what you do unto the right side of the equation. Let's take a look at an equation. If we begin with A equals B, what can we do to both sides of this equation? Well, we must do the same thing to both sides. For example, we can add 20 to both sides. That gives us A plus 20 equals B plus 20. The solution to this equation 2 is exactly the same as the solution to equation 1. Adding 20 to both sides does not change the solution. We can take the A and B and multiply both sides by, say, 1/3. 1/3 times A, 1/3 times B. We get the same thing. We can divide both sides by something. For instance, by -4. So A divided by -4 is the same as B divided by -4. Always, as we work with our equations, our goal is the same. The goal is to get the form variable equals constant, or the other way around, constant equals variable. We must get the variable alone on one side of the equation. We usually prefer the left side, but it's perfectly correct to put it on the right side. The variable must be alone, and then a constant on the right-hand side. So, for example, we could have the variable, let's say, x equals a constant, maybe 20. If you see a statement like this, you know exactly what x represents. Or, if you see 20 equals x, you know exactly what the variable represents. Either way, you know that that variable represents the number 20. That's what we're after when we solve equations. Now, what can we use to solve equations? We begin with the addition property of equations. This one, again, is a major rule. Be sure to write this down. Put it on your list of properties and rules to learn. This says, adding the same expression to both sides of an equation does not change its solution. Adding the same expression to both sides of an equation does not change its solution. We can add the same thing to both sides of the equation, and the solution remains the same. We use this in the following way. We remove a term. Remember, a term is something being added. Remove a term from one side of an equation by adding its opposite to both sides. The addition property is used to remove a term from one side of an equation. Remember, however, that when you add something to one side of an equation, you must, by the golden rule, do it to the other side, and so we have both sides here. We must add the opposite of the term we want to remove to both sides of the equation. Let's look at some examples of putting this rule to work. In our examples, we want to solve each of the equations that's given. Let's begin with x plus 8 is equal to -3. x plus 8 is equal to -3. We want to get the variable by itself. That means that we want to have nothing on this side of the equation except the letter. The 8 is in the way. We want to remove it. Let's use the addition property by adding -8 to this side of the equation. Remember that if we add -8 to this side, we must add it to the other side as well. So our second line reads, copy the original equation, x plus 8, and the -3 are copied. We add -8 to both sides of the equation to eliminate the 8 that's to be removed. So we have x plus 8 add -8 equals -3 add -8. On the left-hand side, the 8 and -8 add up to 0. In effect, they cancel. On the right-hand side, no canceling. On the left-hand side, we have just x. On the right-hand side, we get -3 plus -8, which is -11. Adding -8 to both sides of the equation removed the 8 that was in the way. And we got variable equals constant, which is our goal. Now, how can we be sure that that's the right answer? To check an equation, let's go through the process of asking the question, is -11 a solution of equation x plus 8 equals -3? Remember what to do? We copy the equation, draw the line under it. We then draw a vertical line below the equals mark, and then write a set of parentheses for the x, copy the 8, copy the -3. In place of the parentheses, in place of x rather, we'll copy -11. -11 plus 8 is -3. -3 equals -3. That checks just fine, which means that our answer is x equals -11. Let's do another. Our equation this time is -4 equals y subtract 9. Notice that the variable is on the right-hand side. The extra number with it is 9, but 9 is being subtracted. Remember, however, that subtract 9 means add -9. So let's change this to add -9 right here. Now we need to eliminate the -9. This on the same side of the equation with the y. We'll add the opposite of -9, which is +9. So we'll add +9 to both sides of the equation. This gives us -4 add 9 equals y plus -9 add 9. Notice that the -9 and +9 on the right-hand side cancel. That leaves -4 plus 9, which is 5, equals y. To check this one, we'll do the same thing as usual. We'll copy the equation, fill in place of y, the parentheses, and then inside the parentheses insert the number 5. On the right-hand side then we have 5 subtract 9, which is the same as 5 add -9. And that gives us -4. This checks, and so 5 is the correct answer for y. We have a choice in a problem like this. If it is bothersome to you to have the variable on the right-hand side instead of on the left, we have another way to work the problem.